So, so for this week, we'll be discussing about week 4 contents of the course on wheeled mobile robots. Again, this week is mostly corresponding to sensing and perception, sensing and sensors and sensing. So weeks 4, 5, and 6 mostly related to sensing, then locomotion, then navigation. The 3 weeks course would be handled by Professor Ashokan from IIT Madras. Okay, so we'll discuss the problems, sample problems concerning week 4 for the course wheel mobile robots. So if you are having any doubts in following me or any concerns regarding my audio visual clarity, quality, or if you have any doubts in between, you can always interrupt and yeah, let me know. So we'll get on with the session. Yeah, the first question says, which of the below system is constrained to perform tasks having least complexity, given the robotic systems have at least sensing and perception capabilities? So it says, which of the following system is constrained to perform tasks having the least complexity? So the options are remotely operated mobile robots, or would it be teleoperated surgical robots, or an autonomous underwater robot, or hybrid robots? So different categories of robots are given. So these two are more or less comes under same category. It's either remotely operated or teleoperated, doesn't matter. Then you have a keyword for the third option called autonomous. Then hybrid, which can switch to autonomous, or it can switch to teleoperated mode, however the user pleases. So the keyword here to look for is to perform tasks having least complexity. All right. Given the robot have at least, it should be having the least amount of, at least it should be having some sort of sensing and perception capabilities. So what would be the correct option? So if you have gone through the lectures, you might have seen a slide regarding the classification of robots and the applications on which it would be employed. So as you can see, the first option is basically yeah, excuse me. The first option is basically remote operation. So remotely operated robotic systems are mainly employed for tasks having more complexity, and the mode of operation would be usually teleoperation. So yeah, you might have seen medical robots, medical surgical robots. So these robots typically comes under remote operation category or teleoperation category, where a surgeon would typically perform the surgery elsewhere, not exactly at the point of incision, maybe some other workstation. And whatever movements that is made by the surgeon's finger, it will be de-amplified or amplified with very accurate precision on the patient's point of incision. So the entire motion of such robots are based on this teleoperation. And the task complexity would be usually very severe. So in case of complicated surgeries and all these things, you would employ teleoperations regarding tasks that are very complex. So remote operation is mainly used for complex tasks, and the mode of operation would be mostly teleoperation. Whereas in case of autonomous robots, autonomous robots, robots having high level of autonomy, they would be mostly employed for tasks that are least complex. Because in order for a system to be autonomous, it should have sensors, then it should have some perception capabilities to extract data from the raw sensor data. It should have some cognition abilities to plan what the robotic system is going to do. So all sort of these things are basically sensor based. So sensor, as you would know, they are not very accurate, and you would have some error models to error models to propagate whatever error that is happening in sensor all the way to the control input. So due to the fact that sensor being not accurate, it cannot be used. As of now, it cannot be employed for higher complexity tasks. So as the autonomy increases, the application at the complexity of the task which it would be employed would be further decreased. Whereas in case of hybrid robots, these would be supervisory, because it can have a certain amount of autonomy, but it will have to be supervised by a central node or a centralized node actually, and the task complexity comes somewhere in between remote operation and autonomous robots, right? And hybrid vehicles can basically switch to direct teleoperation mode for complex tasks. So if the complexity of the task increases, it can with the command it can basically switch to teleoperation. And for simple tasks, if it has some other necessary onboard sensors, it can switch to autonomous modes. So going back to our question, which would be the most appropriate choice? So I hope you all would agree if we are choosing an autonomous underwater robot as the correct choice. Yeah, because remotely operated and teleoperated, these can basically take any tasks of very high complexities. Whereas hybrid robots would come somewhere around somewhere in between autonomous and teleoperated robots. Whereas autonomous robots would only be, as of now, would only be capable of tasks that are least complex. So in this regard, the most appropriate solution would be an autonomous underwater robot regarding this question. Right? Yeah, so the answer is indeed option C, autonomous underwater robots. So yeah, moving on to question 2. Yeah, the process by which people translate sensory impressions into a coherent and a unified view of the world around them. Choose the process for which the above statement suits the best. So yeah, what would be the most appropriate choice? So again, I'm reproducing the slides from the lectures, week 4. So if you have a real world environment, so using the sensors, the perception part basically creates an environmental model. And it's already written here. It basically creates an environmental model, and it creates a local map of this environment. So what are the basic steps of this perception model? So the perception basically deals with sensing. Sorry. Perception basically deals with sensing. So it also extracts raw data from the sensors. Raw data from sensors. So whatever information it can retrieve from the sensors, it will basically retrieve information extraction. And it would feed on to the localization module. So perception basically deals with sensors. It extracts raw data. It will basically extract whatever useful information that is available from the sensors. Then it will feed on to localization. Localization basically deals with the question where the robot is currently situated. So with the available local map, the robot will have to locate itself onto the created local map. Then the cognition state. The cognition basically deals with planning of where the robot should be going. So the question, where am I going? All these things, where am I going? So basically, cognition deals with the question, where am I going? And localization basically deals with where am I? So yeah, the cognition state basically creates a path from the start to goal position. Start creates basically a path plan, and yeah, the start to goal point. So cognition basically deals with planning of a path from its start point to the targeted goal position. And motion control would deal with how do I get there? The question, how do I get there? Then usually using actuators that comes in between, it will basically interact with the real world environment. So in this regard, the question basically says, process 5 is people translate sensory impressions into a coherent, unified view of the world around them. So people translate sensory impressions into a coherent and unified view of the world around them. So the raw data goes into the process, comes with information, useful information. So yeah, basically for the the general control scheme, basic control scheme that have been presented in this slide. So the most appropriate module or the most appropriate process out of all the 4 would be perception, right? So out of localization, cognition, motion control, the most appropriate option would be perception. Because perception is what that deals with sensors, extracting the raw data from the real world environment and then converting into useful information so that it can be fed into the later processes, which are localization, cognition, and motion control. So, excuse me. So I hope we all can agree on that regard. So the correct option in that regard would be perception. We'll check the answer. So the answer is indeed perception. All right. So yeah, moving on to question 3. Select the sensor systems which cannot be classified as both exteroceptive and active sensor systems. So the keywords are which cannot be classified as exteroceptive or active sensor systems. So I hope we are basically at this point of time we are familiar with the exteroceptive and active sensor systems. So sensors can be classified basically into 2 different categories. So one is proprioceptive sensors. The second one would be exteroceptive sensors. So proprioceptive sensors are sensors that basically senses data that is internal to a robotic system. That is internal to a robotic system. And exteroceptive basically measures parameters or variables from the environment, measures variables that are external to the system. So a typical example for proprioceptive sensors would be encoders, for odometry. Examples would be odometry or odometers. And a typical example for exteroceptive sensors would be maybe proximity sensors. So this is one classification of sensors. It could be either proprioceptive sensors or exteroceptive sensors. And another classification of sensors are whether the sensor is active sensors or the sensor is passive. So in this regard, active sensors basically, active sensors are basic sensors that are basically powered, or it'll basically emit an energy. And it will also have provisions to sense whatever if there is a change in this energy, whatever energy be, whatever form of energy be that, due to the presence of any external disturbances, if there is any change in quality of this energy, active sensors can basically measure. But in case of passive sensors, it doesn't. It need not be powered. These are not powered, but will sense whatever changes that are occurring in the environment. So senses changes from the environment. Right, and a few examples in this regard would be, what would be the few examples? So a typical example for an active sensor would be ultrasonic sensors. Basically, it would have to emit ultrasonic waves to see whether an object is in close proximity with it. Another example would be a mechanical gyroscope. In case of a passive sensor, it would be a mechanical gyroscope. Right. So yeah, the question basically asks, select a sensor system which cannot be classified as both exteroceptive and active sensor systems. So if you again recall the slide from the lectures, so in these cases, our first option is basically it's contact switches. So as you might know, contact switches comes under tactile sensors, and contact switches are basically passive. We need not provide any energies into it, but it is exteroceptive, contact switches, because it measures, basically contact switches measures any changes, or it basically measures deformation, so that it will basically create a change in voltage because of the deformation that is happening onto that due to the tactile disturbance onto the contact switches. So tactile sensors are exteroceptive and passive. So we would want the question basically seeks proprioceptives and passive. So in that regard, the option first is not correct because it is exteroceptive and passive. Then non-contact proximity sensors. So again, proximity sensors comes under, if you look at these options, proximity sensors are also basically tactile sensors or proximity sensors. So it also basically comes under this classification. Tactile sensors or closeness, whether an object is close to it or not. So non-contact proximity, that is again exteroceptive, but in this case, these are active. So this is exteroceptive and active. Again, we cannot select this option because it is exteroceptive and active. So our question needs proprioceptive plus passive. This is what we are looking for. And optical barriers. Again, this is not optimal barrier, this is optical barriers. Optical barriers also comes under tactile sensors. So optical barriers, all these are basically exteroceptive sensors, and optical barriers is also an active sensor. So again, we have to rule out this option because again, this is also an exteroceptive sensor and an active sensor. But what about gyroscope? Gyroscope is basically a sensor that measures the orientation orientation of a robot with respect to a frame of reference. And if you're talking about mechanical gyroscope, these are basically passive sensors. And these are proprioceptive sensors also. Proprioceptive. Yeah. Proprioceptive. So this is also a correct option. These are proprioceptive sensors. One of the options is correct. Again, Doppler radar that is used for detecting motion of a body. It can be used to find out velocity of a moving body. Again, Doppler radar is basically an exteroceptive sensor, but it is also powered, so that also becomes an active sensor. And what about optical encoders? Optical encoders are basically proprioceptive, and again it is this is basically active. These are basically active sensors, optical sensors. Optical sensors are proprioceptive and active. I hope you can see that. So the question says, select a sensor system which cannot be classified as both exteroceptive and active. So which would be the correct option? Optical sensors are proprioceptive and active. This cannot be selected. Doppler radar sensors are exteroceptive and this cannot be selected. So the only possible choice at this moment would be gyroscope. Because contact switches, all the contact switches are basically exteroceptive. Yeah, so it can be ruled out. And out of the proprioceptive sensors, only gyroscope and optical encoders are proprioceptives. But optical encoder is basically an active sensor. So our only option would be gyroscope. Sorry. Yeah, our only option would be gyroscope. Right. I hope you can recall this slide from the lectures. Yeah, but this is basically taken from a previous year's syllabus. It says option A, D, and F. But the correct option here is gyroscope only, because option D, option A is basically an exteroceptive. This is basically an exteroceptive sensor. And option F is also an active sensor. So in this regard, which of this option cannot be classified both exteroceptive and active sensors? So A would be exteroceptive and passive. Option F would be exteroceptive and active. And this would be, sorry, this is exteroceptive. Proprioceptive. And gyroscope would be again proprioceptive. And passive. Whereas option B, C, all these others are basically non-proximity. These are exteroceptive, active. Optical barriers, these are also exteroceptive, active. Doppler radar is also exteroceptive. Okay, so in this regard, I think the question is correct only. It says it cannot be classified as both exteroceptive and active. So we have to rule out both exerosective and active would be, if we are ruling out exerosective and active, option B would be ruled out. Then option C would also be ruled out because B and C are exteroceptive and active. Option E would also have to be ruled out because that is also exteroceptive and active. And the remaining options are option A, option D, and option F. Because neither of them are exteroceptive and passive. So our correct option, again, our correct choice would be option A, D, and F. So again, it's easy to get confused with this question. The wording of the question, I'm not sure. It's easy to make this mistake actually. So correct in this regard, you would only get full marks if you select options A, D, and F. Okay, so moving on to question 4. Excuse me. So this is a numerical question. It doesn't have a multiple choice question. So I guess this is the first time that we are coming across a numerical question. So it says we have a robotic system having a mechanical gyroscope which has a following spinning speed and precision speed of 600 RPM and 40 RPM respectively. So we have a spinning speed, omega S would be 600 RPM, and precision speed, omega P would be 40 RPM. And yeah, the mass of the gyroscope is also given. Mass would be 4 kilograms. And the radius of gyration would be 30 millimeters or 30 by 1000 meters. So we are asked to find out the reactive torque in Newton meters. Reactive torque. So if you can recall the formula for the reactive torque would be I, the moment of inertia, I omega S omega P, where S is the spinning speed and P is the precision speed. So do we have this I over here? I is basically if the radius of gyration is given, the moment of inertia would be mk square. This would be 4 times 30 by 1000 square, and omega should be converted into radians per second. So omega S would be 2 pi 600. These are basically speed. It's not omega, angular velocity. These are ns and these are np. So 2 pi ns by 60. 2 pi ns by 60 would be your rotation angular velocity. And if you substitute all the values, I guess this would be around 62.83 radians per second. And omega p, angular velocity of the precision velocity, would be 2 pi times 40 by 60. And again, if you substitute the right values, you would get around 4.19 radians per second. And yeah, the moment of inertia, if you substitute all the right values, you would get 0.0036 kilogram meter square. So if you substitute all these values into this equation for the reactive torque, yeah, the answer would be around 0.94 Newton meters. Because this question specifically asks to find out the value in Newton meters. 0.94, yeah. So if you check the answers, the solution range can have a basic tolerance. So if you plug in a value that is in between any of these ranges, you would get the full mark, the correct answer. So yeah, moving on to question 5. So it says select the wrong statement. So the first statement says so the statement is basically the accelerometers are used in a robotic system for the measurement of. Option A says if the displacement, the displacement if the acceleration is known. Option B says the linear acceleration if linear displacement is known. Option C says a jerk on the system, and option D says force acting on the system if mass is known. So yeah, what is the wrong statement? So the purpose of the accelerometer is basically it is basically used to find out acceleration in all three axes of the coordinate system. And the first option says it is used to find out the displacement if acceleration is known. Again, that is not correct because it is acceleration that we are trying to find out. And on integrating this acceleration, we would get the displacement. It's not the other way as mentioned in the question. So we would get the accelerations from the accelerometer, and on integrating the accelerations, so first we would get accelerations from the accelerometer, then on integrating we would get the displacement. But the question says the opposite side of it. That is not the correct option. So obviously statement A is false. So option B says linear acceleration if linear displacement is known. So this is more or less correct, because if we have the linear acceleration, we can basically integrate it to find out the linear displacement. But for that, we need to find out the initial conditions. Initial displacement should be known, and if you are getting the current acceleration, we can integrate it using some Euler method to find out the next acceleration, the acceleration of the next time step. So in that regard, this option is correct. And jerks on the system. So that is also possible, because if you are getting accelerations from the accelerometer, again, if you're taking a derivative of accelerations, we would get the jerk happening in the system. So jerk is basically the third derivative of position, or a second derivative of velocities, or the derivative of accelerations. So if we are having accelerations, we can again take the derivative of it with respect to time to get the jerk on the system. And similarly, if we know the acceleration and if we know the masses, we can easily determine the forces that are acting on the system. So in that regard, the wrong statement would be the first option, actually, displacement if the acceleration is known. So this would be the wrong statement. All the others are more or less achievable, more or less can be realized. Yeah, so if we check the answer, it says, yeah, the wrong statement would be the first option, displacement if the acceleration is known. Because acceleration is what we are getting from the accelerometer, and displacement can be obtained by integrating, double integrating the acceleration. Yeah, so moving on to question 6. It says, which of the following sensors are not incorporated in an inertial measurement unit for estimating 6 degrees of freedom, position, and orientation of a system? So, yeah, basically, inertial measurement units are basically used for, it has basically position, used for obtaining positions and orientation capabilities. So obviously, we'll have an accelerometer to find out the position. So from the accelerometer, we'll get the accelerations. On integrating subsequently, we'll get velocities and displacements or positions. So it most definitely will have an accelerometer. And for determining orientations, we would also have a gyroscope. This is a microelectromechanical system, microelectromechanical gyroscope, a MEMS gyroscope. Whereas optical encoders, these are basically mostly intended for odometry. Mostly intended for odometry, and vision sensors is also an exteroceptive sensor used for some other purposes, but not really used for orientation and positions. So in that regard, which of the following sensors are not incorporated? The keyword is not incorporated. So for positions, we'll have accelerometer. For orientations, we'll have gyroscope. So the remaining two options that are not part of IMUs, inertial measurement units, are optical encoders and vision sensors. So options A and C are the right choice. You have to pick options A and options. So if we check the answer, options A and C are the correct choice for this question, right? Yeah. Again, this is a generic question. The minimum number of satellites required for a global positioning system, sir. So basically, the 3 satellites are required to identify the position. Yeah, 3 satellites are required for narrowing a position of a position using what you called a trilateration principle. The keyword is trilateration principle. And again, a 4th satellite is also used for synchronizing all these satellites, synchronizing the time between the satellites and the receiver at the Earth. Because satellites would be using atomic clocks, and yeah, those would be, because of the relativity, there will be some offset between the atomic clocks of the satellite and the clocks that is basically in the receiver. So 3 satellites would be used for trilateration, and plus 1 satellite for synchronization. So plus 1 satellite for synchronization. So in total, we would require at least 4 satellites to fully identify, fully locate a positioning of an object or a receiver that is basically covered by all the 4 satellites. So if you can recall from the slides, the GPS system of USA will have 24 satellites. So in total, it will have around 32 satellites, and 24 satellites are employed full time for global coverage. It can cover, it can basically cover the entire Earth using 24 satellites. And the remaining 8 satellites are basically standby. Like if in case out of the 24 satellites, if one get damaged, the standby satellites can basically replace. So the total number of satellites in the US-based GPS would be 24 active satellites, but you would only require 4 satellites to fully locate a receiver that is within the range of all the 4 satellites. So again, in that regard, the correct option would be option 4. The number of satellites required would be 4. So moving on to question 8. Again, this is also a new question. It says a floor cleaning robot is placed at position A. So the robot would be at position A, and it detects a position at it detects an obstacle at position B. So we have an obstacle over here. This would be position A, this would be position B, with the help of an ultrasonic sensor. So the sensor value are as follows. The speed of wave propagation is 340 meters per second. So speed of wave would be 340 meters per second in the medium. And the time of flight would be 0.04 seconds. Time of flight would be 0.04 seconds. So it says find the distance between A and B. find the distance between A and B. So in that regard, what would be the correct option? So here the keyword is basically, it says time of flight. So what does this mean? Time of flight means basically the transmitter and receiver are both part of the robot. So the time of flight basically means the time at which the sound would take to go from position A to B and then reflect back to from B to A. So this is the total time of flight. So to find out the distance between A and B, if you simply apply the formula, distance is simply velocity times time, and the time would be half of time of flight. So in that regard, the correct substitution would be 340 times 0.04 by 2. This would be around 6.8 meters. I guess around. Clear, because time of flight is basically the time the sound travels from B during the transmitter stage and then from B to A during the receiver stage. So just to find out the distance between A and B, we have to take half of time of flight. All right. Yeah, so in that regard, the correct option would be 6.8 meters per second, where distance would be simply a product of speed of sound times the time of flight between A and B. That would be half of the entire time of flight. So 340 times 0.02 would give you 6.80 meters per second. All right. So again, this is a question regarding proximity sensor. So select the principles which are used in proximity sensors. So what are the principles? Whether inductive principles are used in optical sensors. It is correct basically because we basically use eddy currents. So generation of eddy currents is the principle that we use in inductive proximity sensors. So due to electromagnetic induction, if a metallic object is approaching the proximity sensor, so eddy current would be generated on the metallic surface, which in turn would change due to the magnetic induction, which would basically changes the behavior of the oscillator in the proximity sensors. And in case of capacitance, we also use capacity sensors. So basically the presence of an external object or an external body, would change the capacities. So the introduction of an external body can be sensed by the change of capacitance using a capacity sensor. And what about Ohm's law? We basically don't use Ohm's law in proximity sensors, non-contact proximity sensors. Ohm's law cannot be employed. Light intensity modulation can also be used, because the way at which the object basically reflects the light, how much fraction of the light the object absorbs, or how much it would transmit back, the angle of incidence, all these things can be used for measuring the intensity of the light modulation. Again, light intensity modulation can also be used for detecting a presence of an external body for a non-contact proximity sensors. And again, ultrasonic sensors can also be used. So based on the time of flight of the sound waves that is reflected by the object, again we can determine the location of an object. So if an object is close by, the time of flight would be very minimal. So inductance, capacitance, light intensity, and ultrasonic waves. These principles can all be used for non-contact proximity sensors, whereas Ohm's law cannot be used for proximity sensors. It has not been implemented as of yet. So again, the correct options would be options A, B, D, and E. All the four except C. Yeah, options A, B, D, and E: inductance, capacitance, light intensity modulation, and ultrasonic wave propagations. So yeah, moving on to question 10. It says, according to the error propagation law, the output covariance is given by the relation where CY is the covariance matrix representing the propagated uncertainties for the output, and CX is the covariance matrix representing the input uncertainties, and FX is the Jacobian matrix. So we are asked to find out the right relation between output and input covariance matrix. So as you might have seen, we would use encoder data, that is the data obtained from the wheels. So basically sensors would always have an error. We'll assume some error distribution to the input, and if an error distribution, if we are assuming an error distribution for the input, that is the data from the sensors, then what would be the error distribution of the output? So output in the sense would be the control input that we would be giving onto the actuators. So if you are creating a model, if you are modeling an error input, an error model for the input signal, what would be the corresponding error model for the output signal that we would be giving as a control input? So again, this is a straightforward question. The correct option would be option B, Fx, Cx, Fx transpose, where Fx is simply a Jacobian matrix that would basically relate the input and output relation. The partial derivative of the input, partial derivative of the input vector with respect to the output vector, the usual Jacobian matrix. So again, that is a straightforward question. We are only required to find out the mapping between input covariance and output covariance for error propagation. Yeah, and the correct option is, as we discussed, option B. This is also straightforwardly discussed in the lectures. So we'll also discuss a few of the questions that has been covered in the assignments, because the deadline of the assignments are all over by now. So we can also discuss. If you are having any doubts regarding the assignment questions, you can also let me know. So a few of the assignment questions we'll be solving. So this question says, dash is a method that is used for controlling a robotic device remotely by human operator. So the options are telepresence, autonomous operation mode, navigation, or teleoperation. So obviously telepresence is the process by which physical presence, even if a physical presence of a person is not being possible, a presence of that entity can be realized using some sort of an interface. So in case of an online classroom, even if the teacher is not from our institute, if he's from another institute, his presence can still be ensured using some sort of an interface. So such kind of a method is called telepresence. So a person physically need not be present. It can be present. His presence can be ensured using some sort of an interface. So that is telepresence, but that is not what the question asks. And the second option is autonomous operation mode. Again, that does not match with the question. It says controlling a robotic device remotely by a human operator. Again, autonomous operation mode does not fit that description. Navigation is also totally unrelated, not relevant to the question. And teleoperation, that would be the correct option. So one of the examples would be in case of an area where people cannot access. In case, so for example, in case of during the Chernobyl disasters, so people would send robots to inspect the area around the blast. So as you might recall, the blast basically happened in reactor 4. So they cannot send human beings because the radiations are basically so fatal. So humans cannot survive there for long. So instead of sending humans for inspection, we could send robots. And these robots are controlled by a human operator at a safe pace. So all the inputs, all the motions of the robot are basically controlled by a human from a safe pace. So that entire process is called teleoperation. And that is exactly what the question says, the question demands. Controlling of a robotic device remotely by a human operator. So again, the correct option is option D, teleoperation. And yeah, question 12. Choose the correct statements. So again, the question regarding the question regarding all the entirety of week 4 are basically descriptive. So we'll have minimal number of problem solvings as we have seen in previous weeks. So again, choose the correct statements. It says the first option says proprioceptive sensors gather information from robot's environment. So that is obviously false, because it is exteroceptive sensors that gathers information from the robot's environment, not proprioceptive sensors. And moving on to option 2, exteroceptive sensors measures value internally to the system. Again, that is false. So it is proprioceptive sensors that measures value internally to the system. So basically, the definition switched in options A and B. So what about option C? Option C says passive sensors acquires energy from the environment for the function. So that is basically true. So we need not provide any more energy to aid its functioning. So that is correct. And in case of option D, active sensors emit proper energy and measure their reactions. Excuse me. So that is also correct. Option D is also correct. So in case of ultrasonic sensors, it would have to emit an energy and it will have to measure the total time that is required for the sound to reflect back onto this receiver. So active sensors basically emit proper energy and measure their reaction. That statement is also true. And passive sensors do not emit any energy, does not require any power for the functioning also. They will simply acquire their energy for their functioning from the environment. So for example, the contact switches. So we need not provide any additional power to the functioning of contact switches. So in this regard, both options C and D are correct. So this is a case of multiple correct answers question. So both options C and D are basically correct. Right. The option C and D are correct. And question 13 is a match the following question. So it says a general classification of sensors in one column and the corresponding example of a sensor system in the second column. So we are supposed to match the following from the first column to the second column. So we'll start one by one. So what are these tactile sensors? Tactile sensors, an example of the tactile sensors would be contact switches. The contact switches are an example of tactile sensors. So the first option corresponds to Option D. And yeah, we'll move on to the second option, wheel motor sensors. So wheel motor sensors, whether they are brush encoders, whether they are, an example would be GPS, CCD cameras, contact switches, inclinometers, Doppler effect. So wheel motor sensors are basically used for odometry. And yeah, we would have brush encoders are one example. We have optical encoders. All sort of these encoders are basically wheel encoders, mostly attached to the wheel of a robot, so that we can get the number of times the wheels would rotate using these encoders. So brush encoders are one example. Another example of wheel motor sensors would be optical encoders, all the other sort of encoders. Second option corresponds to option A. And the third one is basically heading sensors. So heading sensors basically corresponds to the orientation of the robot. In case of a planar robot, a land-based mobile robot, what are the corresponding sensors that we can use for heading? So whether are those GPS, the unselected options are GPS, it won't be correct, CCD cameras, inclinometers or Doppler radars. So again, inclinometers are mostly used for measuring elevations, how much a robot is elevated. In that regard, the correct option, most appropriate option would be, in case of heading sensors, it would be inclinometers. Third option would be E. And the fourth option corresponds to ground-based beacons. Yeah, so ground-based beacons are used to locate an exact position of a body. So ground-based beacons basically, like it can be used for locating ships if we have buoys in the seas. So using coordinations from all the different buoys, we can basically find out the exact location of the exact location of a ship or a body that is moving through the water if it has a sensor. So again, GPS basically comes under this category, ground-based sensors. So option 4 corresponds to yes, and 4B. And what about option 5? Option 5 is motion-based sensors. The remaining options are CCD cameras and Doppler effect, option C and option F. So obviously Doppler effect is corresponding to motion-based sensors, because as you might have aware, the Doppler effect basically corresponds to the change of frequency. Like if a transmitter and a receiver have a relative motion between them, the receiver would basically receive a different frequency, an apparent frequency that is different from a transmitted frequency, that is different from the actual frequency. So based on the difference between these frequencies, we can identify the speed at which the relative motion between a transmitter and a receiver. So motion-based sensors would correspond to Doppler radar, and the vision-based sensor would be CCD cameras. That is the only remaining option. So the correct choice would be 1D, 2E, 2A, 3E, 4B, and 5X, 6C. That regard. So what would be the correct choice? 1D. I think option E is the right choice, right? Sorry, option B is the one choice, correct choice. 1D, 2A, 3E, 4B, 5F, and 6C. Corresponding to the option. Yeah, option B is the correct choice. Moving on to question 14. Which of the sensor performance characteristic fits the following definition? So yeah, dash is the minimum difference between two values that can be detected by the sensor. So what would be the correct answer? So we'll go one by one. So dynamic range is basically, if you recall from the lectures, it is simply the ratio of maximum to minimum values or maximum to minimum limits. And these would be usually expressed in decibels. And range would be simply an upper limit of value that can be measured by a sensor. And resolution is the minimum difference between two values that can be detected by the sensor. So in this regard, the correct option would be resolution. So the question says the minimum difference between two values that can be detected by the sensor. So the correct definition would be resolution. And for the sake of completeness, we'll also define, we'll also give out the definitions of the remaining characteristic. So linearity is basically the variation of output with respect to inputs. And bandwidth is the speed at which the sensor can provide a stream of input signals. So bandwidth is the speed at which the sensor can provide its data stream or a stream of inputs. And again, cross sensitivity, it would be the sensitivity to the external environmental parameters. So if you are measuring a value, if the environmental parameters external to the target value have some influence on the value that we are measuring, so that corresponds to the cross sensitivity of a sensor. So it would be sensitivity to the environment parameters orthogonal to the target measurements. So if you have a target value and due to the influence of the environment, if the measurement of the target value fluctuates a lot, we can say that the sensor has a very high cross sensitivity. So that is not a desirable characteristic. We need to bring it down in most cases. So in this case, the correct answer would be resolution. Because the question says the characteristic that defines the minimum difference between two values that can be detected by the sensor. So obviously the correct answer would be resolution. Okay, so yeah, resolution would be the correct answer. So again, moving on to the, again, this is a numerical. So the question says if the measured value by a sensor is 35 units, the measured value is 35 units, and the true value is 37 units, then what is the accuracy of the sensor? So what would be the accuracy of the sensor? So the correct formula for the correct formula that we apply for obtaining this accuracy would be a 1 minus measured value minus true value, the whole divided by the true value. So if we substitute this thing, 1 minus 35 minus 37 by 37. Yeah, the correct answer would be around 0.946 units. So this would be the correct answer. Again, this is also a formula-based numerical problem. Not much of a concern, I guess. Again, the right answer would be 0.946. Okay, again regarding wrong question statement, capacitive proximity sensors can detect both metallic and non-metallic objects. So yeah, capacitive proximity sensors can detect both metallic and non-metallic. It doesn't matter whether the object is metallic or non-metallic. So the very presence of an external object can cause a change of the dielectric capacity or the capacitance of the capacitor. So it doesn't matter whether the object is metallic or non-metallic. It still can detect the presence of an object. So option A is correct only. And inductive sensors are more accurate than capacitive sensors. Again, from that is also a correct statement. It's basically from the course, directly lifted from the course itself. And the minimum number of satellites required in the global positioning systems are 24. So this is generally not correct. We only require 4 sensors to exactly pinpoint the location of a receiver on Earth with an error of around 5 to 7 meters. We only require 4. 3 satellites for triangulation and the 4th one for time synchronization. But see, the GPS of US have employed 24 so that a global coverage can be obtained. But the systems that are used by India and China, they don't have global coverage. They basically have geosynchronous satellites, not intended for global coverage. So it need not be 24 satellites. We only require 4 satellites to exactly pinpoint the location of a receiver on the surface of the Earth. That is the wrong statement. And the contact switches and bumpers are passive sensors. Again, like as we have discussed in the beginning of this session, we have established that contact switches are also passive sensors. So again, that is a true statement. So in that regard, the only wrong statement would be option C. So this is what we would be selecting. This would be the correct choice for this question, question number 16. And question 17, this is related to Doppler effect used for motion sensing or sensing the velocity of a object in motion. So it says the siren of a police car emits a wave of a frequency at 1200 hertz. So if we treat the police car as a source, the frequency of the source is given as, I think I made it. Yeah, frequency sorry for that. Frequency of the source is given as 1200 hertz. The police car is moving with a constant speed of 30 meters per second away from a stationary observer. So the velocity of source is 30 meters per second. That is away from receiver. And it also says that the receiver is stationary. So the receiver is 0 meters per second. So what is the frequency of the siren the stationary observer will hear? So F, stationary observer or stationary receiver. This is what we are supposed to find out. And we have also given the speed of sound. Speed of sound, C, is given as 340 meters per second. So again, this is a common phenomenon that we have all observed, the Doppler effect. So depending on the relative velocity, relative motion between source and frequency, we would perceive a different frequency rather than this actual frequency that is emitted by a source. So the correct relation between the frequency of the source and the frequency of the receiver would be frequency receiver ratio frequency receiver frequency and the source frequency are directly proportional to the relative velocity of observer and relative velocity of receiver and relative velocity of source. But in our problem, receiver velocity is basically 0, as it says the receiver is basically stationary. So our problem simply corresponds to this formula, C over C plus or minus source. So we would have to use our judgment to see whether the correct sign would be plus or minus. So from our practical experience, we see that like if we are stationary, if an ambulance is passing by, so as it approaches us, the frequency gets increased more and more as it approaches us, and as it goes further and further away from us, the frequency basically decreases. So basically, in the question, we have been given a frequency of the source to be 1200 hertz, and in the question it says that the frequency of the source is moving away from the it is moving away from the stationary observer. So compared to the actual 1200 hertz, the receiver would be hearing a lower frequency because the source is moving further and further away. So whatever we would be perceiving, whatever the receiver would be perceiving, whatever the receiver would be perceiving would be less than 1200 hertz because the source is moving further and further away from the receiver. So in order to make this ratio negative, less than 1200, the denominator has to be positive, right? The denominator has to be positive. So then only we would get a lower frequency. Otherwise, the denominator, if the denominator is negative, we would get a frequency that is greater than 1200. So in that regard, F receiver would be 1200 hertz times C would be the velocity of the sound, V source, the velocity of the sound, that would be 340 as per the question, divided by 340 plus 30. Right. So this would be the frequency at which the receiver would, frequency at which the receiver would be getting. And in that regard, the correct option, if you substitute all the numerical values, the correct option would be option, option C, 1102 hertz. So if we check the answer, the answer is indeed option C, 1.02 hertz. Right. So I guess that is the end of the session. So far we have covered a sample questions that would be similar to the assignments for week 4, and since the deadline of the assignment 4 is also over, we have also covered some of the we have also discussed some of the solutions that have appeared in assignment 4 also. So I hope week 4 is straightforward because the questions are more or less descriptive rather than numerical based, problem based questions that we have seen in the previous weeks up to week 3. All right. So the numerical questions are basically minimal from week 4 onwards. Week 4, week 5, week 6. We'll have a minimal set of numerical questions. Most of these questions would be of similar pattern. That would be mostly descriptive. So yeah.
So these videos will be also shared with us.
Sorry?
I think the live session videos also will be shared with the potential.
I can't hear actually. So I can't. Could you type in Dr. Ashok? Sir, could you
Yes, sir,
type
I
in?
will do
Could you type in the chat box? I can't.
2 minutes, sir.
Yeah. Murali, do you have any questions?
No, I'm fine, Isaac.
Oh, okay. Regarding the video, yeah, it'll be posted by tonight itself. So yeah, it should be available, right? All the previously discussed videos should be available in the course website.
Thank you, Ji. Thank you.
Yeah, if you go to the course website, you can get a set of all the previously conducted live sessions. So
Okay, Ji. Thank you, Ji.
you can access, access that. Thank you. So anything else?
Nothing, Ji. Thank you, Ji.
Okay.
Well understood, because
Okay.
one problem I was being made assignment was wrong.
Okay. Which question was
I
that?
conducted a. Yes, sir. It is now clear to me.
Which question was that?
That 11202 last question, Ji.
Okay. I hope you.
Now it is clear.
Yeah, you got the clarity regarding this this one.
Yes, sir. Only the sign has been problem to me. Now I got clarity. Thank you, sir.
Okay. Because the basic principle would be F receiver by F source. This is simply a relative velocity C plus or minus V receiver by C plus or minus V source. So yeah, this is our question. So in the case if the receiver is moving, if the source is stationary and the receiver is moving, as we move further and further away, we'll get a lower frequency, right? So in that case, if you want to make the numerator smaller, the sign would be plus if the receiver is moving away, and if the receiver is moving toward, we'll have a higher frequency. So in that case, if you want to make the numerator higher, we'll have to add plus. So it depends. The question, we need to see what the question says, whether the receiver is stationary, whether the source is stationary, whether the source is moving away from the observer, whether it is moving towards the observer, whether the receiver is moving towards the observer, moving away from the observer. So all these scenarios are possible. So depending on the scenario, the sign plus or minus changes should happen. Right. And for the question, this question, it says V receiver is obviously 0 and V source is moving away from the observer. So away from the observer means the observer would be listening to a frequency that would be less than the transmitted frequency from the receiver. So if you want to make this whole fraction less than 1, this numerator will have to be greater. This numerator will have to increase. So in that regard, we'll have to select the plus option. But if the other case was asked, if the question said that the receiver is moving towards the observer rather than moving away from the observer, if the question says moving towards the observer, then the numerator, would have been numerator would have been C minus V source, right? Then if you multiply F source onto the other side, we will get a value that is greater than 1200.
Now very clear.
Yeah. That is the logic behind. So yeah, thanks for tuning in. If you don't have any further questions, you can.
Thank you, Ji.
Thank you very much, sir. you don't have any further questions, you can leave.
Thank you, Ji.
Thank you.
Thank you, Isaac.
Thank you, Murali. Thank you. Thanks for tuning in.
Bye.